All right, so we just did 4 proofs and we're going to do some more because the way to learn proofs is to do proofs, to watch them, to do them together. It's very important, though, that you are thinking about the steps and about what I'm talking about here as you do it. Don't just write what I write. That's not learning. Okay? Write what I write, but think about what you're writing as well. Okay? So with proofs, we are going to start by writing the given information. I have 2 pieces of given information. I think I'll put this one first because anytime I have the word midpoint or bisect or perpendicular, something that's like a geometry vocabulary word in my given, that's going to tell me more than one step. It's going to tell me something, and then the next step is going to be explaining what it's telling me. So I'm going to start with this one. So angle PRQ is congruent to angle SRQ. And the reason I know that is it was given to me. And I'm going to check that off, and then I'm going to go mark it on the picture. Now, this is where you see that if you have struggled with 3-letter angle names, it becomes very important that you're careful about it. So PRQ, PRQ. So R is the vertex, that's this angle right here. And it's congruent to SRQ. SRQ is over here, R is the vertex. Here we go, okay? So I've marked one pair of angles that I got. Next up, the other piece of given is that QR, segment QR, bisects an angle, angle PQS. That was also given. Now, whatever is being bisected gets divided into 2 smaller congruent pieces. So if an angle is being bisected, that tells me I'm going to have 2 smaller congruent angles. So that's what's going to be in the next step. So let's look at the picture. QR, it bisects angle PQS. Let me just highlight angle PQS. That's this whole big angle. That's what's being bisected by QR. It's being divided into 2 smaller pieces. So that's this side and this side are 2 congruent smaller angles. So I got to be careful with my letters, my order. PQR, that's one angle, is congruent to SQR. And you could have called either one of those opposite RQP or RQS. Q has to be the middle letter, though, because that's the vertex. So that is, how did I know that? I knew that because you told me that QR was bisecting the big angle. So that's the definition of angle bisector. And I'm using that little symbol to mean angle, just to fit it all in. Definition of angle bisector. All right, so looking at my picture right now, I have, or my figure, I have 2 pairs of congruent angles. Is there anything else that I'm supposed to know without being told here? Yep, I've got a shared side. I've got this side in the middle that QR is a part of both triangles. So it's going to be the same size no matter which triangle it's in. So that counts as a pair of congruent sides. So I'm going to say QR is congruent to itself. And the reason anything is congruent or equal to itself is the reflexive property. Every time my 2 triangles have one side where they join, I'm going to say that. I'm going to say, okay, this side is congruent to itself, and the reason I can say it is reflexive property. All right, so now I do have 3 pieces of information. I got a pair of angles, I got a pair of angles, I got a pair of sides. Don't pay any attention to this order that you've mentioned them in. Make sure you look at the order that they're actually located in. So in other words, I have 2 A's, 1 S. I need to decide if the pair of sides is the included side, the side that is in between the 2 angles. And it has to be that for both triangles, is it? Mm-hmm. Yeah. This is the angle in between, this is the side in between those 2 angles on the left triangle, and it's also the side in between these 2 angles on the right triangle. So when it's the included side, that means my reason is ASA. The S is between the 2 A's. And that's how I know that triangle PQR is congruent to triangle SQR. Your last statement is always going to be the thing you were asked to prove. All right, next up. Proof 6. It starts out by telling me that AC bisects angle BAD and AC bisects angle BCD. This is one that you got to be really careful about seeing what this means, because sometimes I'll have students make an incorrect assumption here, and I'll show you what I mean in 1 second. I'm going to start with AC bisects angle BAD. That is given. And then again, here's a geometry vocab word. When we have one of those, the next step is going to explain what this means about congruence, about congruent parts. All right, so AC, here it is in the picture. AC is that segment in the middle, and we're saying it bisects angle BAD. Let me highlight BAD. BAD is over here. So if this is the angle that's getting cut into two smaller parts, then my two smaller angles are both going to have vertex A. They're going to be over here. Excuse me. So this angle and this angle. So angle BAC must be congruent to angle DAC. And I know that because you told me it bisected it, that this segment bisected this angle. So that's the definition of angle bisector. And by the way, if I haven't mentioned this, an angle symbol can be written like this or like this. It really doesn't matter. They mean the same thing. I tend to kind of go back and forth. All right. So the mistake sometimes students make is if they see this information, they're like, okay, if these two angles are congruent, these two angles are congruent also. They're not necessarily. You have to have that information. But in this case, we do have that information. That's what this says over here. It says that angle BCD, which is this angle over here, is also bisected by that same segment. So this side, this angle, and this angle are congruent. So step 3 is saying that it bisects. You have to state the given before you can talk about what it means. That's the given. And then what it means for us is that these two smaller angles on either side of AC are congruent. So angle BCA, and you could call it ACB, is congruent to angle DCA. DCA or ACD. And again, same reason, excuse me, because that's the definition of angle bisector. All right, so we've got a bunch of things we know. We've got two angles, really, two angle pairs. Here's an angle pair, here's an angle pair. That's 2 pieces of information. We need 3 to be able to say triangles are congruent. What segment or angle is my third piece of information about? AC, right? That segment in the middle. We just talked about this in the last one. If you have a segment that is part of both triangles, and AC is, and by the way, it can be helpful to you if you want to draw them separately, to separate them and look at them something like this. And say, yeah, that's a pair of congruent sides. So here we go. And every time it's just the same side in both triangles, we're going to say it's congruent to itself. Side AC is congruent to itself by reflexive property. And that is what tells me these two triangles are congruent by what triangle congruence? ASA. You are correct. ASA. 2 angles and the side between them, 2 angles and the side between them. All right, so our next proof says given segment SR bisects angle QST, that's one piece of given information, and the other piece is that angle SQR is congruent to angle STR. I think I'm going to start with this one. It really doesn't matter, but I'll tell you why I decided to do that in just a second. All right, the reason why I decided to do it, let's go ahead and mark this one before I go on and check it off. SQR is this angle right here. STR is this angle right here. All right, the reason I decided to state that SR bisects angle QST second is because, remember when we use the word bisect or midpoint or perpendicular, we then have to explain how that gives us something congruence-wise. Like that alone doesn't really help me with triangle congruence, but the fact that it's telling me SR bisects, and let me trace this big angle, QST, tells me that SR is like a knife chopping that angle into two smaller congruent angles. And so that's going to be my next step. So these two kind of go together. So angle QSR, QSR, the perils of using a pen, is congruent to angle TSR. And that's because you told me that SR bisects, chops it in half like a knife, this big angle QST. So that's the definition of angle bisector. All right. So now I have a pair of angles, another pair of angles. Is there anything else I know? Because remember, we have to have 3 pieces of information to use any of our triangle congruence shortcuts or theorems or postulates. All right, so let's see. I have a segment that's in both triangles. Segment SR is in the left triangle and it's in the right triangle. The one on the right, it's not a right triangle necessarily. And that means it's congruent to itself. It's the same size in both of those triangles. So I'm going to say SR is congruent to itself. And the reason for that is always going to be reflexive property. Anytime you say something's congruent to itself or equal to itself, it's reflexive property. All right. And last but not least, whatever I'm being asked to prove, that's the finish line. So it will always be the last statement on the statement side, because if you haven't gotten to that conclusion yet, if you haven't shown that these triangles are congruent, you wouldn't be done. And if you have shown it, then you're done. So these triangles are congruent by, and remember it has to be SAS, SSS, ASA, one of those. All right, so I see 2 angles and another side. The question with that always, if you have 2 angles and one side, is whether the side is the side that is included between the 2 angles or not. For these 2 angles, this would be the included side, the side that goes between them. Same thing over here. For these 2 angles, this would be my included side. So if it were that red side that I knew about, it would be this one because the side would be between the 2 angles. This is the side I know about. I know SR is congruent to itself. That is not the side that goes between the 2 angles. So it's the non-included side. And remember, this is the same thing. It doesn't matter which order you say it in. We usually say excuse the bell, really. We usually say AAS, but some people probably usually say SAA. It doesn't matter either way. It's just saying 2 angles and the side that's not in between them. We could write it either here, but not in between them. All right, and our 4th and final proof for this particular video. Given angle XWZ, I'm sorry, I did want to make one other point on that last one. Remember when I accidentally said right triangle when I meant the triangle on the right? I actually had someone ask me today, oh, can we use the fact that those are right angles? They sure do look like it, don't they? But we're not told that they are. If you are not told that you have right angles, and there are a couple of different ways you can be told that they're right angles. They could be stated. You could be told they're right triangles, or you could be told that this segment SR is perpendicular to QT. That would be another way of saying these are right angles. But you have to have that information. The fact that it looks like it does not tell us anything. It could be 90.5 degrees for one of them and 89.5 degrees for the other. It could be really close to 90, but not 90. So don't try to avoid making assumptions. For our final proof in this set, let's just look at it before we jump in. Let's look at it and think about things we know. Because at this point, hopefully you're starting to notice some of these patterns and things are starting to come to you, oh, I could write this. And that's really how learning how to do proofs works, is you get the experience and it starts to help you. You start to realize, oh, you actually know what the next step might be. Whereas at first it seems very strange and that doesn't seem like it makes sense at all necessarily. All right. Well, at least that's the experience a lot of students have. Maybe that's not you. But I do know I've got two pieces of given information. So I know that one of them is going to go here and one of them is going to go here. And both of these are going to say given. That's something I know. I also know that this triangle congruent statement is going to go down here. It's going to be the last statement. And I know that this side, the reason for it is going to be one of those 5 triangle congruence postulates or theorems. Sometimes we just call them shortcuts or reasons. One of these 5 is going to go right here. Another thing I can tell, just looking at this is one of those cases where the 2 triangles have the same segment in both of them. XZ is in both triangles. So I'm probably going to mention XZ being congruent to itself, and the reason for that is always reflexive. So I know a lot of things even before I start this proof. So let's go to it. All right, step 1, I'm going to state this given first. Angle XWZ is congruent to angle XYZ, and that's a given, and I shall go mark it. XWZ, there's W is the vertex, XYZ, there's the vertex. We mark it at the vertex, and then I'm going to check it off. Then the next given I have here is segment XZ bisects angle WXY. Also given, 2 things I know here. One is if I use a geometry vocab word like that as a given, there's going to be a statement after it. There's going to be another step where I sort of explain what that means for my 2 triangles. Okay, and for bisecting, if it's an angle being bisected, and let's trace that angle, WXY, when an angle is chopped in half, it gives you 2 smaller angles. So this is going to give me 2 smaller congruent angles. So angle WXZ is congruent to angle YXZ. And that's because you told me it was an angle bisector. This angle was bisected. So definition of angle bisector. All right, so we've got 2 pairs of angles. We haven't mentioned that side, that segment that's in both triangles. So I'm going to go ahead and mark it and say, well, let's talk about it. XZ is congruent to itself. You could call it ZX if you'd rather. And the way we know anything is congruent to itself, reflexive property. All right, so I've got a pair of angles and a pair of angles and a pair of sides. 2 pairs of angles and a pair of sides. That means it's going to be one of these 2. Remember that what matters here is not the order in which I said it. In other words, I mentioned a pair of angles here, a pair of angles here, a pair of sides here. It's nice to take stock of that and go, yeah, I have 2 A's and an S. But that doesn't mean it's necessarily this one. I have to look and see if the side is between the 2 angles or not. So let's look at where is between the 2 angles. Between the 2 angles would be right here. Between the 2 angles in the other triangle would be right here. It is not the side in between. This is the side that's marked, which is not the side in between the 2 angles, which we call the included side. So it's not the included side, so it's not going to be this one. Therefore, it's going to be this one. So we have triangle XWZ is congruent to triangle XYZ by angle, angle, side. And that brings us to the end of this set of 4. Look for another video in which we use HL. Thanks for watching, and I will see you next time.